Okay, so this is the question. Coefficient of friction between the table and the block shown is 0.2. So here coefficient of friction is 0.2 at this surface, and rest of the two blocks are hanging. Find the tension in the two strings. So how do we find tension in the two strings? So for that, what we need is we need to write equation for three objects. So suppose tension here is, suppose we name the masses first. So this is suppose MA, this is MB, and this is MC. Okay, three masses. Then tension we can take T1 here. Okay, so T1 is trying to pull it up, and T1 is trying to pull the upper object leftward, and T2 is trying to pull it rightward, and T2 is trying to pull it upward. Okay, so these are the tensions and the masses. Okay, now we will write the equations. So for A, if you write for A, so for A, the downward force is MAG. Downward force is MAG, upward force is T1. So net force will be how much? MAG minus T1. That is the net force on this object. This will give acceleration MA into A. So all the three objects will have same acceleration. All the three objects will have common magnitude of acceleration. So we can write it like this. Okay. Similarly for B. For B, if we say T1 is pulling left, T2 is pulling right, and friction will act opposite to it. Why we are considering like this? The movement will be, since it is heavier mass, 15 kg is hanging, so it will pull the whole system down. So this 5 kg will go up. That's why we are taking friction in rightward direction. Okay, so we will write for this object T1 minus T2 minus friction equal to MB into A. And friction, how much we can write friction? Friction will be mu times the normal. The normal is here. Okay, so mu times normal. And now normal we know on a horizontal surface, the normal is equal to mg. So mu mbg. So this is the normal force and mba. So we can write it like this. This is for B. This is equation 2. Now equation 3 for third object, for 3. So mcg. So tension is upward, mcg is downward. So tension upward minus mcg downward equal to mc into A. Okay, so these are the three equations. Now we have to find the tension in the two strings. So first, the best way is to first find the acceleration. So if you add all the three, add equation 1 with 2 with 3. So what we will have is, if you add these three, tension will get cancelled. We will have only MAG minus MBG, mu MBG minus MCG equal to MAA MBA plus MCA. Okay, so A is coming how much? G MA minus mu MB minus MC divided by MA plus MB plus MC. Okay, so if you put G and put all the values, so MA is 15 minus mu is 0.2, MB is 5 divided by 15 plus 5 plus 5. So you will have, this is 1. So 15 minus 5, 10. So 9. So that is 90 by 25 we are getting. 25. Okay. So 90 by 25, that can be written as 18 by 5. So this much acceleration we are getting. Now if we have this acceleration, we can find the different tension. So for tension T1, so T1 can be written as MAG minus MAA. Okay, so what is MAG? So MAG is, how much is MA? 15. 15 into 10 minus 15 into 15 by 5. So this we have to do. So 15 and 10 minus 18 by 5. So it will be 50 minus 18 by 5. So how much is this? 18 by 5, and it will be 32. Whatever we get, this is 3. So we are getting 96 Newton. We are getting 96 Newton for T1. Similarly, for T2, if you want to find for T2, we have to write another equation for this equation. This one we can use for T2. For T2, we have to write MCG plus MCA. MCG. So how much is MCG? 5 kg into 10 plus 5 kg into A, that is 18 by 5. So it will be 5 and 10 plus 18 by 5. So how much it will be? 50 plus 68 by 5. 5 by 5 into 68. Okay. So we are getting 68 Newton. So in this way we can calculate the tension in the two strings.